Maybe. Maybe secretly. Secretly, he cares in here. All right, so 22-4, we're going to solve right triangles. So we're going to calculate angle measures using trigonometric ratios, and we're going to solve right triangles. And so tomorrow, I know some of you, slightly less than half of you, will be at the triathletics events. And so we are going to review in class tomorrow, and then I will give the quiz. And so if you're not going to be here tomorrow, I have the quizzes printed, and so we can just kind of read through those real quick at the end of the period. That way it makes sense, and you can start work on that. The only thing is there will be a homework assignment today, so kind of pace yourself. Don't do too much math at one time. And I will make sure that tomorrow's video that I'll record the answers for today's homework so that you have those. Maybe I can print those and just post it on the. But if I post it on the class website, will you look at it? Or would it just be easier to put it at the beginning of the video? You get more YouTube views that way. Okay. I'll just put it at the beginning of the video.
I got distracted.
All right, so the answers for today's lesson, because you'll have a homework assignment for today, but there's also a take-home quiz that I'll be giving tomorrow, passing out tomorrow. And so the answers for today's homework, I'll make sure that there's whatever video I do tomorrow, they're at the beginning so you can check your work. So then you're not doing a take-home quiz with yeah. At least, you'll say, hey, I don't know what I'm doing, and then you can let me know before class on Monday. All right, so in a right triangle ABC with acute angle A, you know that sine of A equals square root of 3/2. Draw a possible right triangle ABC. So I'm going to draw a triangle. We're going to label it ABC, right? All right, so does C have to be the right triangle based on the information that we have?
No.
No, because it could also be B. But is the right angle A? No, because it tells us acute angle A. All right, so now knowing sine, I forgot, what's the chant that we do? Let me do that first. So SOHCAHTOA. So this is sine. So which one of these represents sine? So sine equals opposite over hypotenuse. So this is opposite over hypotenuse. So from A, what's our opposite side? CB, and what do we know about the length of CB?
It equals to the square root of 3.
And then our hypotenuse, which side is our hypotenuse? And we know its length is 2. All right, so what do we know about this side over here? It's adjacent to A. Can we find its value? Okay, we can use Pythagorean theorem, right? But hold on, stop the presses. Does this format look familiar if I put a 1 in front of here?
Yeah.
What kind of triangle is this?
It's
30, 60, 90. So if this is 1 times the square root of 3, then what's this side going to be? So in a 30, 60, 90, how does the hypotenuse relate to half? So this is 1, right? And then this side is the square root, this side times the square root of 3. Is that, kind of familiar? So what type of triangle is this?
30, 60,
Just to kind of refresh. Does that ding a bell? Some of us need a small little tap, others need like the whole gong thing. Alright, so we could recognize that it was a 30, 60, 90 based on pattern. But what happens if do you think there's a way of using this? So we found A. A is A a 30 degrees or a 60-degree side? 60 or 60? Alright, so do you think that's like the best way to find an angle measure? It was one way, right? But what happens if it's not a 30, 60, 90 or 45, 45, 90? What if it's like any other triangle? So what we're going to do is there's another way we can do this. You'll notice where you have sin, cos, and tan. If you push your second button, you'll have sine with a little inverse, cosine with a little inverse, or tangent with a little inverse.
It has like a -1.
Oh, above it. Alright, so what we're going to do now is, so this is how we undo. So this little inverse, it doesn't mean like 1 over. What it means is undo it. So if we have sine of A equals x, we can inverse sine x, and that allows us to find the measure of angle A. So algebraically, what it looks like, so we have sine of A equals square root of 3 over 2. That's what we're given up here, right? So if I inverse in algebra, remember, whatever you do to one side, you have to do to both. So this is undoing each other because they're opposite functions. So now I'm just left with A. And then if we do inverse sine, parenthesis, square root of 3 divided by 2, what do we get? Here it says 60, incorrect.
I got 60.
I don't know how to do the fraction thing.
So it's like 36 minutes, 45.
Oh my gosh.
All right. So all of our trig functions have inverse. They have ways of undoing. So to undo sine, you do inverse sine. To undo cosine, you do inverse cosine. To undo tangent, you do inverse tangent. And all that does is it separates the trig function from whatever is inside, from the angle measure inside. So let's do some practicing. So here, using a scientific or graphing calculator to evaluate each of these, make sure you're in degrees. I think all of you are. So we're going to do inverse sine of 1/2. So what if we do inverse sine and then 1/2? So you can either use the fraction button, or remember 1/2 is 1 divided by 2. So if you, the fraction is great, but you can always do divided by 2. All right, so what's cosine? Inverse cosine of 1/2 is. All right, what's inverse tangent of 1/2? So go ahead and figure those out. I don't need to read them all, and then we'll go over them. Oh, I think Tel's been waiting. All right, did we all get those values? Any differences? I sometimes have difficulties with the calculator. Fingers are kind of fat and they hit the wrong button. So they all match? All right, so using known measures to find all the remaining unknown measures of a right triangle is known as solving a right triangle. So what's nice about this is if you're given two sides of the triangle, now you can find that third side, and you can also find all of the angles. So it's nice. Right triangle, side nothing. All right, so Trisha designs the logo shown for one of her clients. She needs to know all of the missing dimensions and angle measures of the logo. So I use an inverse trig function to find the measure of angle Q. So we know it's a right triangle. We know this side is 33 millimeters. Side SR is 65 millimeters. And we need to find QR, and we want to find, I'm just going to ignore this. We want to find everything else. So how could we find the hypotenuse? Give me two ways that we can find it. Okay, so teacher's manual. Okay. So we can use Pythagorean theorem. How else can we find the hypotenuse? We can use SOHCAHTOA. Specifically, which two can we use? So and Ka have hypotenuse in. All right, so let's find, what do you want to find first? We want to find angle Q, R, and QR. Q. So looking at Q here, I want to find its angle measure. So what two sides do we have? If we're looking at Q. All right, so we have adjacent and opposite. So which trig function relates adjacent and opposite? Right, tangent. We have our TOA. So we have tangent of angle Q equals, what's our opposite side from Q? It's looking across at. And our adjacent, it's holding hands with. All right, so looking at this, we need to undo our tan function, right? So how do we undo tangent?
Whatever it is.
So we're going to do inverse tangent. So this gives us that Q equals inverse tangent of 65 divided by 33. All right, so what do we get for this one?
63.082.
Oh, my calculator's not working quite right. Hold on, user error, actually. There we go. All right, so we got Q equals 63.08 degrees. Now, can we find angle R?
Yeah.
Yes. Two ways that we can find angle R.
Triangle sum or something.
Yep. So the triangle sum,
Yeah.
all the angles of a triangle always equal up to 180. We know two of the angles, so we can find that third. How else could we find it? SOHCAHTOA. All right. So let's see. If you want to use the triangle sum theorem, do it that way. The rest of us, let's do SOHCAHTOA, and we'll compare our answers. They should be the same. So from R, because we're going to use TOA again. So from R, TOA is opposite. So what's our opposite side? 33. And our adjacent side? All right, so we need to separate tangent from R. And so we use our inverse. I'm going to show we're doing it in a calculator. He's not alone. He did. Garrett's not going to be there when we're all working on our homework, so we need to make sure that our calculators work too. All right. So 26.92 degrees. So that's our measure angle R. Did anybody do triangle sum theorem? Did you get the same thing? All right, good. All right, so now we need QR. So we have three options of finding the length of our hypotenuse. We can either use SO, CA, or Pythagorean theorem. So who would like to do Pythagorean theorem? What's that? Okay. Who's going to use SO? All right, CA? You're either using SO or CA. All right, so let's find our hypotenuse. So if we're using SO, sine, here's sine. Now it depends which angle you're looking at, right? So does it matter which one you use? As long as it's Q or R. So if we're setting it up for Q, sine of Q, what's our opposite side from Q? 65. And our hypotenuse is what we're trying to find, right? I'm going to call it X for now. Oh, and we know what Q is now, right? It is 63.08. So make sure you put that in. And then we can also do sine for R. So looking at R, what's our opposite side? 33. And our hypotenuse. And so make sure for R, we're putting in 26.92. And then we can always, flip it to do cosines of the angles as well. But there's lots of options. So even for sine and cosine, there's 2 options for sine, 2 options for cosine, in addition to Pythagorean theorem. The options are almost, talk about freedom of choice, right? Freedom of speech in your math class. Do you like that one? Alright, so kind of reviewing from class yesterday. I want to find out, I need to get, this is a number, and this is what we want to find out, right? So I have sine of 63.08 equals 65 over x. How do I get x out of the denominator? This is 65 divided by x, so I'm going to multiply. And whatever I do to the right side, I have to do to the left. That cancels. So now we have x times sine of 63.08 equals 65. That seems like a lot of letters, right? But is this special? No, this is just saying that it has some decimal going on over here. So I want x to be by itself. So how do I separate these two? I'm going to divide, because it's x times the sine of 63.08, and to undo multiplication, we divide. So when you multiply, divide by the same thing, it cancels. So now we have x equals 65 divided by sine of 63.08. And it makes sense, we're dividing by a decimal, and we want to make sure that our value, QR, is something greater than 65, because the hypotenuse should be the longest of your 3 sides. All right, so what do we get for QR, regardless of how you solve it?
72.9.
All right, so Garrett got 72.90. All right, so we got a confirmation. Do y'all have questions on this? How are we feeling about this? Pretty okay? Pretty okay till we start the homework?